Hello class, we're about to start section R3.9, Finding Quadratic Models. It says let F of t be the average annual expenditure in thousands of dollars for people in the U.S. at t years of age. It's the data from the 2012 U.S. Statistical Abstract. Using your calculator, construct a scattergram of the data including scale and labels. Okay, first of all, the age is here. This would be L1 and this would be L2. So you need to enter this in your calculator. I don't have the simulator, so I'm going to tell you step by step how to do this. Number one, the first thing you should do is press stat. Number two, press enter. Number three, you will enter L1 and L2. Number four, you will press second and Y equal. Number five, you will press enter. Number six, you will go until you get to the word on and then press enter. So again, number six, you will press your arrow key until you get to the word on and press enter. Okay, now number seven, you will go to zoom. And then number eight, you will press zoom stat. I don't know what number that is, but you will press zoom stat and that should give you your graph. Okay, so now you see your graph. Now looking at your graph, you will go to B. It says considering the scattergram from part A, does it appear better to use a linear, exponential, or quadratic function to model these data? If you look at your graph, it looks like an upside down parabola, right? So parabolas are quadratic. So your answer here would be quadratic. Actually, I should have made it capitalized. So it should be quadratic. And then you could put because the points go up, and then back down. Okay, now it says find a quadratic regression model for f of t with your calculator. Okay, taking that same information that you had from what you did in A, just press stat, and then you would press your right arrow to calculate, and then you will go down till you get to quadratic, I guess it's quad red, and then press enter. And then you will keep pressing enter until it gives you your answer. Okay, now that it has given you your answer, your quadratic model, we know we're going to have f of t, and that will equal to a negative 0.032 t squared plus 3.14154t. Now, I didn't leave myself enough room, but then it'll be minus 20.721. And this should be the equation that you derive. Okay, now, just like I told you all from the first day of class, you should leave your diagnostics on. If you left your diagnostic on, you can easily find R2. You can go back and do what we did. Well, when you got C, your answer for C, it should have your R2. So your answer should be 0.970. And it says describe the strength. You know that is a strong relationship, or strong relationship, or the strength is strong. Okay, now The next page, we basically have all of the directions as far as using your calculator. It shows you how to do a few things in your calculator to get your answers. And then it also shows you how to do it in Excel. Then here we go to example 2. Now example 2, it says here, let F of t be the number of deaths of motorcyclists and accidents in thousands in the U.S. at T years since 1980. Okay, now we look at this graph here. This graph looks somewhat like a parabola. So we know this graph is quadratic. So it's quadratic. And then it's because, if you notice, the graph goes down and then goes up. So you can write that down. The graph goes down and then goes up. That would be your explanation for quadratic. It goes down, then it goes up. Now for B, it says find the quadratic regression model for F of t with your calculator. Give 2 decimal places. So we need to put these values into our calculator. Now remember, this says since 1980. So we know we would do another list here. So then this list would be 5, 10, and it's jumping here. So I will verbally tell you what you should put in for your L1. Because we know the years are L1 and the motorcycle deaths are L2. So this is since 1980. So for L1 you will put 5, 10, 15, 20, 22, 24, 26, and 28. Again, that's 5, 10, 15, 20, 22, 24, 26, 28. And then you would type in these values for your L2. Now, when you type in those values, that will give you, so we get the answer here. Our equation would be F of t is equal to, and we want to round to 2 decimal places, so it'll be a positive 0.02 t squared minus 0.60 t, and then plus 7.14. And this would be your regression model.
Wouldn't it be 0.012 for A?
No, actually it would be, because it said 2 decimal places. If you look at A, you got 0.019. So this would be the answer for B. Now we look at C. It says, what is R2? R squared, if we round to 3 decimal places, will be 0.976. And we know that this is a strong relationship. So it's a strong relationship. Now we go here to D. We want to find F of 25. So we have to put it into the equation that we got up here. So we want to take this equation. Now you could all write this down at D, but it's hard for me to remember all of this, so I'm going to write it here. So you should have F of 25 is equal to 0.02 times 25 squared minus 0.60 times 25 plus 7.14. Now remember, you're writing all of this in D. Now, when you put this in your calculator, in fact, I could use this calculator here. When you put this in your calculator, let's see what we would get. Minus 6 times 25 plus 1.4. So it should give us 4.64. Again, your final answer for D is 4.64. So I'll write that here, 4.64. And it says, what does it mean in terms of this situation? Now, you know that's 25 years since 1980. So it'll be in 2005. There are, there are 4.64. I took the liberty of scrolling back and forth, but this means in 2005 there are 4.64 thousand motorcycle deaths. It's interpolation because this falls in between the amount that our graph has. So if it would have been outside of that amount, then it would have been extrapolation. Okay, now it says find t when f of t is equal to 8. So we need to take this formula here, and we will have 8 will replace f of t, and it'll equal to 0.02, well, we should actually put t, since we're dealing with t. T squared minus 0.60 t, and then plus 7.14. Now what we want to do here, we could do one or two things. We could go through and solve for t, which would take all day. Or we could put this in your calculator. We could set this as, this would be y1, and this right here would be y2. You could put this in your calculator and basically find your intersection points. So what we would have to do is this. Put this, you would put 1, you would go to y equals 2, you would type in 8 for y1, and then for 3 you would type in 0.02 t squared. I just say you would type in a y2 equation. For the purpose of this problem, when you type in y2, you can use x instead of t. It still will give you the same answer. So again, for step 2, we'll put in 8 for y1. For step 3, we will put in this 0.02 t squared minus 0.60 t. Well, we'll put x plus 7.14. Okay, now, after you type in all of that, we have to find the intersection points. So this is what we would need to do. Okay, so now class, again, with the calculator, I'm just going to have to pass on that, because by this time in class, you should know how to enter this into the calculator. So once you enter this into the calculator, we would get 2 intersection points. One would be negative 1.378, and the other one would be 31.37, 8. These would be our 2 intersection points. Okay, so now we go down here to F. It says find the vertex of the model by calculator. Include a sketch of the graph. What does it mean in this situation? Okay, so first of all, what we would have here, according to the graph that you did on your calculator, it would be a minimum point. I did show you all how to do a minimum point before, so you would have to use what you used before to find the minimum point. And the minimum point here would be 15 and 2.64. That would be your minimum point. And so it asks us, what does it mean in terms of this situation? Motorcycle deaths were at their lowest level in 1995 at 2.64 thousand. Okay, so that is the final answer for F. But we need to go back up here because I did not give the explanation. The explanation for these 2 points were there were 8,000 deaths in 1978 and 2011. And that is the final answer.